In this section, we will look at interest compounded periodically. So it could be once a year, twice a year, 3 times a year, quarterly. This formula is the most general formula that handles every situation where it's a periodic compounding. A is the amount in the account. P is the initial investment, the principal investment. R is the interest rate written as a decimal, and that's a per year, an annual rate. M is the number of times per year that it is compounded, and T is the time in years. So let's look at a particular example involving this formula. So the example that we saw, our investment is $10,000. We have an interest rate of 4.75%, which makes R 0.0475. And the time period, we want to know what the amount will be at the end of 30 months. So let's put all these into the formula and see what we can come up with. We're looking for A equals 10,000 times 1 plus the interest rate as a decimal 0.0475 divided by, now this is in months, but the interest rate is an annual rate. So if it's per month that we're compounding, we divide by 12. The M is the number of times in a year, and months would be 12. So this is 12 times T, where T is in years. So let's see if 30 months I need to put in terms of years. So 30 months, 24 months is 1 year, and another 24 months is 2 years. And another 6 months would give us 2.5 years. So this is 10,000 times 1 plus 0.0475 over 12 raised to the 12 times 2.5 power. I did not divide out this decimal and this fraction right here. The reason is, if you take 0.0475 and divide by 12, you get a number that's like 0.003958333. You don't want to chop this off. If we're multiplying by 10,000, those 4 zeros take up a lot of decimal places, so we want to be as accurate as possible. So I am not dividing out and estimating this fraction at all yet. Okay? All of this pretty much needs to be done in the calculator at one time. My 12 times 2.5 gets me back to my 30, because that's the number of months. So I would start in here in the calculator and first put in 0.0475 divided by 12 equals, add 1 equals, raise it to the 30th power, find out what that equals, and then multiply by 10,000. So one of the very important things in working with these values is to actually go all the way through, if you can, in one step. I would write down intermediate numbers as they come up in the calculator. That's why you hit the equal sign fairly often. So you can come up with the final amount of money that you have. So we end up with so once all the calculations are done, we end up with the amount 1125.8.20. We'll have, in 2.5 years, $11,258.20 in the account. This is the interest that's compounded continuously. We have interest that's compounded once a year, twice a year, 4 times a year, monthly, daily. As you get compounding more often, eventually you run into continuous compounding, and it shortens the formula considerably. So we have A of t is equal to P times the E raised to the RT power. Remember that A is the amount in your account. It includes your invested amount and all the interest earned. P is the principal, that's the amount invested in the beginning. R is the interest rate in an annual interest rate in a decimal form. And T is the time in years. It's very important, remember, that the interest rate R time period and the T time period match. So now let's look at an example. So our family is trying to determine how much money to invest at their newborn's birth to end up with $250,000 when she starts college in 18 years. So we need to use this point and our interest rate and try to see if we can come up with our initial value. Now remember, the initial amount, that's the amount to be invested, that's actually P. That's what we're looking for. So let's put our second point into the formula. So A is 250,000 equal to P, which we don't know, times the E raised to the R. In decimal form, R is 0.07 for the 7% interest rate. And our T value is 18. So if I want to solve for P, I can do that first. I think I'm going to multiply these two numbers together before I move anything else around. It's not 0 point, it is 1.26 equal to 250,000. So for P now, I'll take my 250,000 and divide by e to the 1.26. Figure out what e to the 1.26 power is, 250,000 divided by that. I find out that the value for P is 70,913, and we round to 2 decimal places because P is money, it's dollars and cents. So the amount they need to invest in year 0 at birth is $70,913.50 after a fixed interest rate of 7%. 18 years later, that becomes $250,000.